Hello, Pre-Algebra students. This is Chapter 4.4, Least Common Multiple. Earlier in this chapter, we found the greatest common factor of two numbers. Now we'll find the least common multiple of two numbers. Let's get started. A multiple of a whole number is the product of the number and any non-zero whole number. For example, the multiples of 7 would be 7, 7 times 1, 14, 7 times 2, 21, 7 times 3, 28, 7 times 4, and so on. If a multiple is shared by two or more numbers, we call it a common multiple. For example, let's list the multiples of 8 and 12. The multiples of 8 would be 8, 16, 24, 32, and 40. The first five. The first five multiples of 12 would be 12, 24, 36, 48, and 60. 8 and 12 share a common multiple. It's 24. And if we did one more multiple of 8, 48, you could see a second common multiple. However, our least common multiple will be 24. It is the lowest multiple that the two numbers share. Let's use the concept of least common multiple to solve a crop rotation problem. Crop rotation is a system in which farmers vary the crops they plant in their fields every year. Let's suppose a farmer grows alfalfa in a certain field every 6 years. In another field, the farmer grows alfalfa every 10 years. During this year's growing season, the farmer is growing alfalfa in both fields. In how many years will the farmer grow alfalfa in both fields again? So for the crop rotation system described above, the number of years until the farmer grows alfalfa in both fields again will be given by the least common multiple of 6 and 10. So we can use one of two methods to find the least common multiple. First, we can simply list all the multiples. So let's try that first. 6 and 10. So let's start with the first 5 and see how far that gets us. 6, 12, 18, 24, and 30. The first 5 multiples of 10 would be 10, 20, 30, 40, and 50. We have a common multiple, 30, and that will obviously be our least common multiple because it's the first one we've come upon. So in 30 years, the farmer will grow alfalfa in both fields again. Now let me show you method 2. In method 2, we prime factor 6 and 10. So the prime factorization of 6 is 2 times 3. And the prime factorization of 10 is 2 times 5. We identify the common factors, 2. And then we multiply all of our factors together using the common factor only once. So now we will take 2 times 3 times 5. And that will give us 2 times 3 is 6, times 5 is 30. So our least common multiple is 30. Now try a few problems on your own. Find the least common multiple of the numbers listed in problems 1 through 4. You can use whichever technique you prefer. Method 1, listing the multiples, or method 2, finding the common factors through prime factorization. Press pause while you work, record your answers in your homework notebook, and I'll see you in just a moment for the next idea. Now let's find the least common multiple of monomials. If we compare two monomials, 9xy squared and 15x squared y, we have one technique that we can use that will reliably help us find the least common multiple. First, we factor. 9xy squared becomes 3 times x times y times y. 15x squared y becomes 3 times 5 times x times y. We need to identify the common factors. So we have a set of 3's. we have a set of x's, and we have a set of y's. The least common multiple will be calculated by multiplying out all of our factors, but only using the common factors once. So this circled 3 will come down as a single 3, times, now we'll put this 3 in, times, now we put this 5 in, times this x comes in once, times y, times x, times y. Now we work that out to be 3 times 3 is 9, times 5 is 45, x times x is x squared, y times y is y squared. So our least common multiple of 9xy squared and 15x squared y is 45x squared y squared. Let's find the least common multiple of one more set of monomials, since this is a pretty new idea to us. So let's factor 4g cubed h squared, and then find the least common multiple that it has with 15g squared h to the 4th power. So first let's factor 4g cubed h squared. That will be 2 times g times g times g times h times h. Now let's factor 15g squared h to the 4th power. 15 will be 3 times 5. Then we have g times g, and then we have 4 h's. H times h times h times h. So our first step here is to identify our common multiples. Our common factors, excuse me. We have a pair of g's here, another pair of g's here, we have a pair of h's here, and a pair of h's here. Okay, now let's put together our string. So we have 2 times 3 times 2 times 5 times g times g times g times h times h times h times h. So I use this h, this pair of h's, this pair of h's, and this h. For my g's, I use this g, and this single g. All right, now we work it all out. 2 times 3 is 6, times 2 is 12, times 5 is 60. We have 3 g's, so that's g cubed. We have 4 h's, so that's h to the 4th power. So our least common multiple of 4g cubed h squared and 15g squared h to the 4th power is 60g cubed h to the 4th power. Another place that you'll see least common multiple used is for the least common denominator of fractions. The least common denominator of 2 or more fractions is the least common multiple of the denominators. We can use least common denominator to compare and order fractions. Let's do that now. Last year, a winter resort had 144,000 visitors, including 45,000 snowboarders. This year, the resort had 160,000 visitors, including 56,000 snowboarders. In which year was the fraction of snowboarders the greatest? So first, we'll start by writing the fractions. In year 1, we had the total number of snowboarders, 45,000, over the total number of visitors, 144,000. In this year, we would have 56,000 snowboarders compared to 160,000 total attendance. So the first thing we'll do is reduce these fractions because there's no need to work with these unwieldy numbers. First thing we can do is eliminate our zeros, correct? And then we can reduce 45 and 144. I think each of those are going to be divisible by 9. Let's try it. 45 divided by 9 is 5. 144 divided by 9 is 16. Yes, that works. Okay, so now let's take this second fraction and simplify. We have 56 over 160. Both 56 and 160 will be divisible by 8, giving us 7/20. Okay, now we have some numbers that we can work with. In order to compare these fractions, we need to find the least common denominator, which we will find by figuring out the least common multiple of 16 and 20. So the least common multiple of 16 and 20, let's see. Let's list multiples here to figure these out. Okay, let's see. We have 16, 32, 48, 64, and 80. Let's see if the first 5 will give us enough to work with here. 20 will be 20, 40, 60, 80, and I can stop there because there's my least common multiple, 80, which will become my least common denominator. Now let's rewrite 5/16 and 7/20 as equivalent fractions with 80 as the denominator. So 5/16 will become 25/80. 7/20 will become 28/80. So now we can compare. Last year, 25 out of 80 visitors to the resort were snowboarders. This year, 28 out of 80 visitors were snowboarders. So the fraction of snowboarders was greater this year. Let's stop and check our understanding. Please find the least common multiple of these 4 pairs of monomials. Press pause while you work, and I have 4 more checkpoint problems for you when you're finished with these. Now use the least common denominator to determine which fraction of each pair in 9 through 12 is greater. Press pause while you work. We have one final idea for Chapter 4.4. To finish up Chapter 4.4, we're going to learn how to order fractions and mixed numbers. Now, I don't mean order like I'd like a side of fries. I mean order as in put them in order from least to greatest or greatest to least. So we're going to order the numbers 3 and 4/15, 33/10, and 19/6 from the least to the greatest. So the first thing we need to do is write our mixed number as an improper fraction so that we can compare apples and apples. Right now we have apples and oranges. So first we need to convert 3 and 4/15 into an improper fraction. Remember, you do that by multiplying the whole number 3 times the denominator 15. That gives us 45. And then we add the numerator 4, giving us 49. We place that over the denominator. So 3 and 4/15 is rewritten as an improper fraction as 49/15. Now, we need to find the least common denominator of 49/15, 33/10, and 19/6. Because I'm comparing 3 numbers, I'm going to use prime factorization to find my least common multiple. So the prime factorization of 15 is 3 times 5. Of 10, 2 times 5. And of 6, 2 times 3. Again, look for shared factors and only use those once. So our least common multiple is 2 times 3 times 5, if you can interpret it through that mess, giving us 2 times 3 is 6, 6 times 5 is 30. Our least common denominator, or our least common multiple, is 30. So now we need to write each of our fractions as an equivalent fraction with 30 as our denominator. 15 times 2 is 30, so we'll multiply 49 by 2, giving us 98. 3 times 10 is 30, so we'll multiply 33 by 3 to give us 99. 6 times 5 is 30, so we'll multiply 19 times 5, giving us 95. Now we simply need to order our fractions from least to greatest, and we do that by comparing our numerators. So, our numerators show us that 19/6 is the lowest value because it's 95/30ths. So 19/6 comes first. Next up is 98/30ths or 49/15ths or 3 4/15ths. And finally we have 99/30ths, which was equivalent to 33/10ths. And there are our three fractions in order. So from least to greatest, it's 19/6, next 3 4/15ths, and finally 33/10ths. And that's the end of our work for today. Thanks for all of your hard work learning about greatest common multiples. And I will see you tomorrow.